Hello students, welcome back once again to the online lectures of design of steel structures. So in the previous session we have solved a problem over design of built up section. Okay, so we have solved a problem design of built up section consisting of two channels placed back to back. Okay, and we had designed a single lacing system also for that. So basically built up sections are can be designed by using a lacing system, that may be single lacing or a double lacing, or it may be designed by using a batten plate also. So like this, it may be designed using batten plate also. Okay, so in the last session we have designed a built up column by using single system. Okay, and we seen the different types of the steps or the criterias or the clauses we have to refer from IS 800. Okay, so in today's session we are going to solve the same problem. Okay, by again you have to design a built up section, but instead of lacing system we are going to check about the batten plate. So you can see here it is a elevation of batten column, so the plates are provided instead of lacing. And here in the plan you can see this is a plan of channel section. These are placed face to face, instead of that we are placing back to back. Okay, and here the spacing is given. Okay, so this is a just a geometry how the built up column with end batten plates. Okay, so we are going to follow the same procedure what we have done in the previous session. Okay, so here I'll just go through the procedure. Okay, so here what you have to do up to the design of lacing, all the steps remain same, all the calculation remain same, and all the steps remain same. After that, instead of design of lacing we have to design as design of batten plates. We have to design as batten plates. So here I'll just quickly go through the steps what we have followed in the previous session. Okay, so here according to the given data the effective length factor we have calculated, that is because both ends are fixed, so it is 0.65 L K into L. So that is we got the L as 12.025 meter, and assuming the allowable stress 140, we have found a section that is two channel section placed back to back. Okay, so for that we have selected two channels back to back, that is 2 ISMC 400. So area for that it is 12.58 meter square we have got. Then IXX, again we have calculated IYY. Based on that we calculate the spacing between the two two channels. So we got 260 mm. So these steps remain same, all the steps you have to follow same. Okay, again no need to calculate here. Okay, so then again we calculate IYY, then we calculated the slenderness ratio, R minimum. Then again as per the clause number 7.6.1.5 as per page number 48 we have to increase the lambda 1.05 times, so we got 81.56. and based on that for built up section you have to the buckling class is C, so you have to refer table number 9C page number 42. So we will get FCD from that, it is 133.66, and ultimately we got our section is safe to carry the design compressive load. Okay, we got our section, that is PCD load carrying capacity is more than the applied load. So we got the selection the whatever member we have selected, that is safe. Okay, So after that we started with design of lacing. So here instead of design of lacing we have to start with design of batten plates. Okay, so we'll start with the next step, so that is design of batten plates. Okay, so here design of battens, design of battens, design of batten plates. Okay, we are going to start with design of battens. So here the first step is for design of batten, it is spacing of battens. First is spacing of battens, that is as per clause number, as per clause number 7.7.3, page number 51, as per clause number 7.7.3, page number 51. So it is given as, so first condition it is given C by Ry less than 0.7 times lambda, and second one is C by Ry less than 50. Okay, so we have to choose the spacing. So where C is nothing but spacing, C is nothing but spacing, and the C will be list of 1 or 2. It will be list of 1 or 2. So I will just show you that clause here. Okay, we can see here the clause number 7.7.2, so that is for design of battens. You have to refer clause number 7.7.2 for design of battens. Okay, so first it is for spacing. Okay, so here we can see spacing of battens. Okay, so it is given as in batten compression members where the individual members are not specifically checked for shear stress and bending moment, the spacing of the batten center to center of its fastening means connection shall be such that slenderness ratio KL by R, that is lambda, of any component over that distance shall be neither greater than 50 or nor greater than 0.7 times the slenderness ratio of the member. So the C by Ry neither means should be less than 0.7 lambda or 50. So therefore we have to find out C from this. So therefore C, okay, by the first condition C is equal to 0.7 times lambda into Ry. Okay, C 0.7. So lambda, again from the previous case we have calculated lambda already. So I will show you the lambda we have calculated here. So we have calculated lambda in the previous problem, that is we have got it as 81.56. Correct. So we have calculated that is 81.56. Okay, so we'll substitute that here. So 0.7 times lambda is 81.56 and Ry. Okay, so Ry is we have got as 28.3. Ry for channel section we have got it as 28.3. 0.7 lambda into Ry. Okay, Ry. So we have got it as here 1615.70, and again for by using second condition, so that is C equal to 50 times Ry. So 50 into 28.3, so we'll get it as 1415 mm. So we have to choose you have to choose least between these two. Okay, you have to choose least between these two. So therefore C is equal to 1415 mm. So that will be, I'll round here to 1420 mm. So we got the spacing between the batten plate is 1420 mm. So I can show you here. Okay, so we have got this, the spacing between the two plates, it is the C we have provided as 1420 mm. Okay, understood. So next is size of batten. Size of batten. So here assuming again 20 mm dia bolt, so D will be 20 and D naught will be 22. Okay. So here in that first one is in size depth of batten plate. What should be depth? Depth of batten. So again, as per clause number 7.7.2.3 page 51. Okay. So here I'll just draw the sketch. Suppose if this is a batten plate, provided with bolts, like this. Okay. So this will be taken as T dash, and this will be edge distance E dash. Okay, E dash. So here the effective depth, it is mentioned as per the clause, the effective depth should not be less than the distance between the centroid of the main member. So therefore D dash is, you have to get S plus 2 times C y y. So why it is S plus 2 times C y y. So I'll, in the plan, if I draw the channels, two channels back to back like this. So this is nothing but the S. Okay, and the one more is so the centroid will be of the channel section will be somewhere here. Again for this will be here. Okay, so this distance is, this is nothing but CYY. This will be also CYY. So the total will be D dash from here to here. So this will be D dash. So which is nothing but, here I'll write once again, S plus 2 times C y y. So I can see here, so total d dash is S plus 2 times C y y. Okay, understood? So C y y for channel section, where the C y y, it is for channel section. You have to refer steel table for that, then you will get the value of C y y. Okay, so therefore d dash is equal to 260 plus 2 times 24.2. Okay, so the d dash will be 308.4 mm. Okay, then what will be d then? What will be d? Okay, so therefore the depth d is equal to, I can show you here. Okay, यहाँ पे देखो अभी, what will be d now? What will be d? So this is total is d. This total together from here, so that is from here to here, total d. What will be total d now? It will be d dash plus 2 times e dash. D dash plus 2 times e dash. Okay, so here I will show you here, I can show it here. So the d is will be d dash plus 2 times e dash. Okay, so we will take e dash, that is edge distance 1.5 times t naught. Okay, we will get it as 1.5 times 22, so we will get 33. We will take it as 35 mm. We will take it as 35 mm. 1.5 times 22, so we will 33, so we will take it as 35. So therefore d is equal to, d dash is 308.4 plus 2 times 35, so we will get it as 378.4, so that is 380 mm. So we got d is equal to 380 mm. Understood? So this is the depth of plate. So one by one we have to calculate it. So we got the depth now, the depth of plate. So in the figure, if I want to show this, the total depth of plate, we got it as 380 mm. Understood? Then after that, thickness of batten. Next step is thickness of batten. Thickness of batten. So the thickness of batten, again as per clause number 7.7.2.3, page number 51. The thickness of batten plate is taken as 1/58 times S plus 2p. Okay, I can show you that again. So the thickness here, the thickness of batten plate shall not be less than 1/58 of the distance between the innermost connecting lines of river. So that will be 1/58 times S plus 2p. So where pitch is equal to pitch, p is equal to pitch distance. Okay, pitch is equal to, p is equal to pitch distance. So we can take it as p is equal to 2.5 times d. So we can take it as 2.5 times 20, so that is 50 mm. Okay, so 1/58 of S is 260 plus 2 times 50, so we will get this as 7.2 mm. So we will take it as 8 mm. So we got the thickness of plate, the thickness of batten plate is 8 mm. So I'll write T. So we got the thickness of batten plate T is equal to 8 mm. Okay. Then after that, next is length of batten plate. What should be length? Length of batten plate. Length now. Okay. So here we got the depth and even we got the thickness of this plate. Now what should be this length of the plate? We have to find out. Okay. So the length of the plate is S plus 2 times breadth of flange. Okay. So I'll just draw the sketch here. Okay. Suppose we have the column like this and column like this. Okay. And we are going to provide the batten plate like this. Like this. So this length and this is breadth of flange. This is breadth of flange and this is spacing between the two column, and we are providing with bolting like this. तो ये क्या होगा total L will be, so from here to here, so L will be spacing plus 2 times, this will also be F, so 2 times breadth of flange. Okay, so we'll get S is equal to 2 times breadth of flange. So S is 260 plus the breadth of flange is 90 again for channel section if you refer. So we will get length is equal to 440 mm. So we got depth of the plate, thickness of the plate and the length of the plate. So here you can write, therefore provide batten plate of size 440 mm by 380 mm by 8 mm. Okay, 440 length, 380 depth, 8 mm thickness. Understood? So after that, next is intermediate batten. Second one, this is end batten. After that we have intermediate batten. Intermediate batten. Okay. After that, next is intermediate batten. Okay, I'll show you what is intermediate batten and end batten. Suppose अगर आपके पास एक column है like this, and we are going to provide batten like this. And after that also okay. So these plates are, ये जो plates हैं, okay, these plates are intermediate batten plates. इन लोगों को बोलते हैं. So this plate is this and this, which will be provided only at the end. So these are called end batten. End batten plate. Okay, these are all end batten plate. So we have designed end batten. Now we have to design for intermediate batten. Okay. So then again, first effective depth. Effective depth is again, I will call it as D1 dash, Di dash because intermediate. So that will be 3/4 of D dash. Will be 3/4 of D dash. So 3/4 of 308.4. Okay. So that is 213.3 mm and should not be less than 2 times breadth of flange. Okay. So आपको कितना प्रोवाइड करना है इंटरमीडिएट बैटन का डेप्थ 3/4 ऑफ डी डैश 3/4 ऑफ डी डैश. ओके. सो दैट इज 213 एंड दैट शुड नॉट बी लेस दैन 2 टाइम्स द ब्रेथ ऑफ फ्लैंज. अगर ये सपोज ब्रेथ ऑफ फ्लैंज है 90 तो 2 टाइम्स 90 कितना हुआ 180. सो इफ दिस इज सपोज इफ यू गेट 175 सो वी हैव टू प्रोवाइड 180 ओनली. अगर ये 2 टाइम्स ब्रेथ ऑफ फ्लैंज से कम होता है सो वी हैव टू प्रोवाइड 2 टाइम्स द ब्रेथ ऑफ फ्लैंज ओनली. वी कैन नॉट प्रोवाइड लेस देन दैट. ओके. सो नेक्स्ट देयरफॉर डी डैश इज इक्वल टू, then again therefore D dash is, so total, so 213.3 sorry 231.3 plus 2 times edge distance, that is 35. So we'll get this as 301.3 mm. So it will be 305 mm. Okay. So we got the depth. Then thickness is again 1/50th of S plus 2p. So we'll get this as 8 mm only, as we have calculated in the end batten plate. Okay. So therefore, and the length will remain same. So therefore provide intermediate batten of size 440 mm by 305 mm by 8 mm. Okay. This is for intermediate batten. Then next, this much for design of end batten and intermediate batten. Okay. So you have to follow the same procedure up to design of lacing. I told you you have to follow the same procedure up to the design of lacing. Then from design of lacing, if you are asked to design batten, you have to follow the procedure for design of batten. Then after that, next we have to follow the procedure. The next step is design of connection. That the same what you did in design of lacing system. So next is design of connection. Design of connection में आपको क्या करना है? Then again, assuming 20 dia bolt. Okay. So therefore what will happen? So the design strength of bolt, you have to find out. It will be list of shear strength and bearing strength. It will be shear strength and bearing strength. So from this you will get BV. you will get bolt value. Okay, then after getting bolt value, we have to find out the longitudinal shear in column, also the longitudinal shear in the column, which is mentioned in the IS 800. So that is Vt into C by N times S dash. Okay. So where Vt is 2.5% of Pu, 2.5% of Pu. So 2.5 into Pu is 1600 divided by 100, that is for percentage. So we will get Vt is equal to 40 kilonewton. And C we have already calculated, that is 1420 mm. Okay, and so therefore we can calculate Vb. Vb is equal to Vt is 40 into 1420 divided by the number of battens are 2 number of battens between the space C. We have to provide the center to center distance between two battens, so that's a 2 into S dash is again 260 plus 2 times 50. Okay, so we will get Vb is equal to 78.8 kilonewton. So we will get Vb is equal to 78.8 kilonewton. Okay, so therefore the number of bolts will be equal to, so therefore the number of bolts will be Vb divided by bolt value. Okay, that is 78.8 divided by bolt value in single shear. I think we'll get it as 45.27 for 20 mm dia. So we'll get it as 1.74. So we provide two numbers, and for bending resistance provide additional bolt. Okay, so we have to provide the number of bolts, 2 plus 1 additional, so that will be 3 numbers of bolts. So we have to provide 3 number of bolts to resist the bending plus shear. Okay, so this is up to the end of design of batten plates. Okay, and by this we are going to conclude the end of design of compression member. Today we are going to conclude the end of design of compression member. So you go to the both the procedure and you follow the steps. If it is a batten plate, or if you design a built up column with batten plates, and if you design a batten plate with design a built up column with batten plates, and design a built up column with lacings, what is the change? You note down the steps and you follow the procedure for that. Okay, thank you.